Hello, your friendly neighborhood Mr. Stone here, and today we are talking about linear equations. Now, the first thing to take note of here is when we're talking about linear equations, we've got this word in here, line, and that's important because you know, looking at this, that you can expect a line if you ever graph this out. This line reflects a constant change, just like a line is constantly going up at the same rate. That's what a linear equation is going to model, is that same change. So let's take a look at a few characteristics of linear equations. First of all, they've got two variables, usually x and y. You could have other things in here, but more often than not, you will see x and y, but it's just a name, okay? Just know that you do have two variables. You also have constants. These are numbers with values that do not change, and we see these all the time. So a good example of a constant would be like the number 3, or 17, or negative 2.2. These don't change. Variables, quite literally, vary, or they change. Constants stay constant. They do not change. Both are numbers. A variable is still a number, it's just being represented by something that's effectively a placeholder, that this can change, but it's still a number. So let's take a look at some examples of some linear equations. Y equals x plus 4. This works. I have two variables. I've got y, I've got x. Also, I've got both of these to the first power. All linear equations must have variables at the first power. Anything more than that, then that starts to change things. It's no longer a linear function. Okay, so we may have seen this form before. This also is a linear function. I've still got my x, I've still got my y, I've got some a constant here, excuse me. These are just some coefficients, and they're attached to our variables. But nothing to the power of greater than 1 for my variables. This works. This works. Same thing here. Again, the format is a little bit different, but I still have my variable 1, variable 2, and then I've got a constant. I could have something else in here easily, like 12s minus 13r equals 8. That also would be okay. That is a linear equation. Let's look at some things that are not linear equations. So for example, y equals x to the third plus 2. Well, why wouldn't this one be a linear equation? This right there, you've got x to the third power. That does not work because we cannot have one of our variables to be at any power greater than 1. I've got square root of x plus 2 equals y. We cannot have a square root. That does not work. Sorry, not a linear equation. And lastly, down here, I've got x squared plus y squared equals 9. Well, what about this? I've got now two of my variables that are greater than the first power. So again, this does not work. Matt Damon also is not a linear equation. He looks like he should be saying something though. Be like, yeah. Okay. So let's look at one of the popular forms that we'll see linear equations in. If I've got y equals mx plus b. This is very, very common, and also I like it a lot because it is so easy to graph. If you look at your m right there, this, whatever the coefficient of your x is, that's m, this is your slope. And we've probably seen this before. We'll recap that in one moment. This b right here, whatever this is, it is a constant, okay, because your variables are taken care of with the y and the x, but this b is also your y, is also your y-intercept, meaning that it is where the line will hit the y-axis. So this vertical line right here is where x equals 0. This is your y-axis. Okay, it is the y-axis, even though it's x defined by x equals 0. Just keep those things separate, okay? The y-intercept, we said that b is the value there. So the line is going to hit the y-axis at the coordinate right here of 0, comma b. And the line could be going like this. It could also technically, let me see if I can draw carefully here. Yes, there we go. The line can go from top left to bottom right. That works too. You're not limited in that the lines can only go bottom left to top right. But still, that y-intercept is going to be defined by 0, comma b. That's where you know, if you know where b, then you know where that line is going to hit the y-axis. Another thing to look at here is this stuff on the right that I put with the triangle x, triangle y. What that really is delta x and delta y. And delta is really just it's a Greek letter that just represents change. Okay, so when you see change, what this is really meaning is the change in x and the change in y. And for linear equations, those are locked in a ratio. There is a ratio of change in y to change in x, and that's what the slope is. Okay, if you need to find the slope, you can use this formula down here. If you have 2 points, you can plug in for, if you have 2 points, x1, comma y1, and x2, comma y2, you can plug those in, you can get your slope. Okay, but quite often you will see your slope in terms of delta y over delta x, or it's just one number. Okay, it can be represented as something like m equals 5.4. It can be m. I don't like that though because it's a decimal, which makes it a little bit tougher to work with. M equals 7 over 3. That's okay. Improper fractions, that's all right. Fractions are okay, particularly for slope, because it helps us graph. Really, the slope is your rise over run. So in other words, the rise is your vertical change. That's why the delta y, it's the change in y for the run. Run is your horizontal. That's your change in x. Okay, let's take a look. I'm giving a lot right here. If you need to rewind, go ahead and do that. Let's take a look at how we can interpret a linear function in slope-intercept form. So if I need to graph this, I've got y equals x, 1/2 x plus 3. So I'm going to start with the b when I graph. This is my what? This is my y-intercept. So I know that I would go up 1, 2, 3, and I've got a coordinate right there at 0, comma 3, because this is my b. That's my y-intercept. Now, here is the awesome part about having your slope in a fraction. Remember we said that this is your change in y, and this is your change in x. So if I go, I've got positive and positive, so I go up 1, and then I can go to the right 2. Up 1, right 2. This is my next point, which would be at, well, I went up 1, so now I'm at 4, and I went to the right 2, which means my x-coordinate is 2, is 2, 4. And I can continue to make more points. You really only need 1 point, 2 points to define a line, excuse me. But you can keep adding more if you wish. This is not the most precise, pardon, I'm scratching it out here. But again, I move over 2 on the x. So now I'm at 4, and I move up on the y, 1. You can also create this as a table, and tables are great ways to see patterns. I start with x of 0 and a y of 3. I add 2 for x, 2, I add 1 for y. Add 2 for x, 1 for y. Add 2 for x, 1 for y. Add 2 for x, 1 for y. And you can see that this rate of change here is staying constant. My x's keep increasing by 2. My y's keep increasing by 1. So it's a fixed ratio of you have a change in 2 for x for every 1 that y is increasing by. And going back to my graph, I can connect the points, and that will give me my line. And this line is defined by y equals 1/2 x plus 3. So let's look at one other way to represent a linear equation. You can see something like this. So don't be too thrown off by this. Really, this part comes from, if we think back at slope. Slope is, we saw the formula earlier of y2 minus y1 over x2 minus x1. If I take the difference in two y values of points and the difference of their x values, that tells me my slope. That tells me my change going back up to here. Okay, if I looked at these 2 points, if I looked at, let's say, let's make this point A, and let's make this point C. If I have point A, which is 0, 3, and point C, which is 4, 5, this would be my x1, y1, x2, y2. I could have my slope equal to y2 minus y1 over x2 minus x1. Plug in. So I've got y2 is 5 minus y1 is 3 over x1 is 0, x2 is 4. Simplify that. I've got 5 minus 3 gives me 2. 4 minus 0 equals 4. Equals, whoop, doesn't equal 0. Equals 1 over 2, which is the same slope that I was supposed to have based on my original equation there, okay? So that this is really where these two things come from. That's just your slope. Okay? The only thing we're doing really is we're taking this and we just simplify it by multiplying the x2 minus x1 on both sides. Cancels out. And that's really the form that you've got there. So you can see this, it's very useful when you know a point and you know your slope. So I've got m equals 5 over 4, and I've got a point A that's at 7, -2. So what I can do is I can substitute. I've got y minus, my y1 here is -2 equals m, we know m is 5 over 4 times x minus my x1 is 7. We can clean this up a little bit because minus a negative number is a positive, so it's y plus 2 equals 5 over 4 times x minus 7. This is a linear equation. You may see something like this. You can, if you want to, you can easily transform it into our good old format of y equals mx plus b. In that case, all you would have to do is distribute first on the right. So this would be 5 over 4 x minus 5 over 4 times 7. And that's y plus 2. This isn't going to be the prettiest thing, but you'd get 5 over 4x minus, multiply these out, that becomes 35 over 4. You want to get the y alone, subtract 2 from both sides, and then simplify. And at that point, you have got a good old slope-intercept form. This would be 43 over 4. Don't forget your x. Okay? So don't be afraid to manipulate these a little bit. Also, one last form you can have. This also is a linear function. X, y are there, and you can have it presented as this: 9x minus 4y plus 2. These are pretty easy to get into slope-intercept form. What I would probably do is add 4y to both sides. 9x plus 2 then equals 4y. Divide both sides by 4. This gives me those guys would cancel out. And then there I've got my linear equation, a little bit more standard form. Remember, linear equations have two variables, usually x and y. The variables are to the first power, and it represents constant growth. Remember, we saw that there was a constant change of x and y. If x is getting plus 2 all the time and y is getting plus 1, that is a solid ratio that continues to build, stays constant, linear equation. Okay? A lot of stuff here. Focus really on these other forms are good to know. You will see them. You'll need to be able to manipulate them, but really focus a lot on this first part, on the slope-intercept form, on what is not a linear equation, and what makes a linear equation a linear equation. Okay? Bring your questions to class and have a great day.